All right. Thank you everyone for joining us today for the webinar, Top 3 Considerations when Designing a Cloud Architecture for Enterprise Scalability on AWS. So I want to let everyone know a few things up top, get through a couple beginning slides, and then I'll pass it over to our presenters. So one, we are recording. If for any reason you need to leave early or maybe you have a colleague who's unable to join, you will be able to view this later on. Two, you can ask questions. I believe we'll have time at the end for Q&A, so please, as soon as you think of something, go right ahead and put it into either the chat or the question panel. We'll be able to take, excuse me, we'll be able to take some on the air at the end. I'd like to introduce our speakers for today. We have Dr. James Bland joining us from AWS. We'll be hearing from him very soon. We have Nick Rendell, product marketing here at CloudBees, and Elliot Landon, a solutions architect here at CloudBees. Before we get started though, I'd like to do a quick poll. We can go to the next slide, please. I'm going to pull that up for everyone right now. So that should be on your screen now. I'd love to see everyone voting, and that's just asking, how is your company utilizing the cloud today? So you can see the options are little, where the majority of workloads are on-premise, hybrid, you have a balanced mix of on-premise and cloud, and then cloud first, where most, if not all of your workloads are running in the cloud. And votes are coming in quick. I'm going to give this a little bit more time. The results have changed quite a bit since the beginning. We'll be showing that in just a moment here. Let's give this maybe 5, 4, 3, 2, 1. Just to share one. So right now, just barely winning is little. So most people working on premise, and then we have a good mix of hybrid, and behind that is cloud first. So to talk about these and everything else we're going to talk about today, I'm going to pass this over to our first presenter, Dr. James Bland.
Thanks, Max. Before I get started, I wanted to level set on the term modernization. You'll hear me talk about modernization and DevOps interchangeably, and they're pretty much one and the same. Modernization came about as a way to differentiate between older approaches to gaining speed and agility and newer modern approaches for basically gaining speed and agility. So don't be alarmed when you hear either, as they are one and the same. Plus, it's also easier to, and it sounds nicer to say modern apps opposed to DevOps apps. So why are customers building modern apps? Customers are building modern applications by enabling their people, process, and technology so they can innovate faster and more frequently and bring those innovations to market faster, all while reducing costs and building more reliable applications. To gain some of the benefits of modern applications, development practices, your journey begins with migration. Assessing your application portfolio and determining the application migration patterns for all of your applications is a critical step to the success of your migration planning and execution. Early cloud adopter CIOs from large enterprises have told us that they want to jump straight to an all-in refactoring all of their applications to take full advantage of the cloud. But this can result in a lengthy design process before moving the first workloads to the cloud. Based on that, we advise you to take advantage of significant lift and shift opportunities to get your cloud migration started quickly, which also means gaining cloud expertise and experience and seeing cost savings quickly. This can jumpstart your refactoring effort. Additionally, you can always refactor after you lift and shift and gain more cloud experience. We also want to call out an emerging new R, relocate. You can quickly relocate applications to AWS based on VMware and container technologies with minimal effort and complexities. So once some basic discovery and assessment has been done, each application migration tends to follow one of the 7 different paths, which builds upon the 5 R's that Gartner coined in 2011. We've outlined 7, and they include relocate, the new R for accelerated migrations. You can move hundreds of applications in days. You can quickly relocate applications to AWS based on VMware and container technologies with minimal effort and complexity. There's rehost. The simplest approach is rehost, aka lift and shift, often representing half or more of the customer's environments, and can typically be migrated leveraging tools that automate the process. As customers progress through their migrations, we often find them starting with re-architecting applications as the default approach, but then lift and shift more and more to rehosting to accelerate their migrations and capture business benefits, then transform their environments over time. Replatform. Some applications require modifications to address specific challenges or provide key benefits, such as reduced licensing costs. Repurchase. A lot of our customers are moving towards the SaaS model and towards solutions like Workday, Drupal, and Salesforce. Refactor. In some cases, you may want to completely reimagine your application architecture and skip right towards state-of-the-art by leveraging the broadest set of container-based, serverless, and managed NoSQL offerings on the market. Then there's retire. You never know what you're going to find until you start looking. And common to us, you'll find that no one knows about 10 to 20% of the enterprise IT portfolio does, and it can simply just be shut off. Retain refers to workloads that you may never move to AWS. Finally, our customers tell us that having hundreds of examples of past customer success is one of the reasons they find AWS the easiest platform to migrate to. We continue to mine our experience so that we can accelerate customers through commonly encountered migration scenarios using prescriptive guidance and best practices. Migration is a big step, but there's still work to do after migration, and having access to features and functionalities will enable you in taking the next steps. I want to share some of the best practices and lessons learned at Amazon around deployments and deployment safety. Note that you don't see very much literature using the terms DevOps or modernization as a practice here at Amazon. That's because the people at Amazon are called builders, and builders build. Also, we've been doing this before either term was coined, so builders has a lot of history with us. So one of the early things that Amazon realized was that to unlock the full potential, we needed to restructure into two pizza teams. These teams were long running, would own a specific set of functionality, and the teams were responsible for both developing and operating the service. They use the you build it, you run it mentality. And I can tell you, when developers now are on the hook for answering late night pages, their mindset shifts, and then they start thinking about writing high quality software that is resilient and self-healing. For Amazon, this change was rooted in the idea of figuring out what was most important to your business, your North Star, by thinking about where you want your business to be in the next 3 to 5 years. At Amazon, we knew time to market was our North Star, so we made a people decision, and then we made some technology decisions to support this. So you want to treat everything as code, not just the application, but also the infrastructure and configuration. Really, it's about how to eliminate manual errors, reduce surface area for things. When we traditionally think of source code, we think of apps, websites, business logic, back-end services, transactions, etc. But now everything is like source code: firewalls, routes, load balancers, identity permissions, monitoring alerts, all of it. In the cloud, all of these resources can be expressed in what is essentially code. Well, to us humans, it's configuration, but as we move through the pipeline, other software and APIs of the cloud platform will turn that configuration into a running resource that performs the same functions as things we traditionally buy and put in racks. By treating your infrastructure as code, you immediately remove the humans from the entire control plane of the network, storage, and compute provisioning and management. You no longer make changes to live running assets. You change them in source control and let the pipeline test and deploy the updates. Using infrastructure as code allows you to lower costs by redirecting resources to more important business needs, improve consistency by reducing human error, which can lead to deviations from configuration standards, agility by increasing the speed at which your organization can release new versions of services in response to customer needs and market drivers, and lastly, improving your ability to attain and maintain compliance to corporate or industry standards due to the absence of repeatable processes. Another important lesson in unlocking deployment speed and safety is that there are no gatekeepers. There's no line to wait in for storage, compute, databases, or to start using machine learning. In the old world, when you asked engineering teams how long it would take to get a server to try an experiment, you get answers like, maybe 10 to 12 weeks. We set out to reinvent this experience to increase the rate at which you could experiment. We thought others would benefit from this, and well, in 2006, AWS was born. Now, in the cloud, you can provision thousands of servers within minutes with 165 services that you can put together and use in whatever combination you want. You get from an idea to implementation in several orders of magnitude faster. This totally changes an organization, increasing the speed and the amount of cycles employees spend thinking about innovation because they know if they have an idea, they have a chance to see if it works. This expands the group of people inside a company that are thinking about new ideas from a select few to everyone. One of the most important ways that we ensure safety and security is through guardrails. Let's look at a philosophical approach to modern operations. One is a free-for-all and the other is centralized control. No one actually considers a free-for-all approach to operations or security, but this is a good illustration of the two extremes available at a philosophical level, fast chaos or slow and order. You can let developers do whatever they want, and they will indeed release very fast. You'll probably also release bad code, reduce application reliability, and even get into legal trouble. On the opposite end, and probably more realistic scenario, we see customers managing operations centrally. They take control of the release pipeline, the process of provisioning resources, securing applications, and troubleshooting. This approach tends to have the perception of safety, but the reality is that central control often creates situations that reduce deployment safety. What I mean by this is that at many organizations, the process for CABs and security reviews are often long and arduous. No one likes to go through this process, so developers try and minimize the number of interactions with these reviews by lumping as many changes as they can. Then when they deploy and encounter problems, they choose not to roll back and try to fix things on the fly. The teams involved with the change know that if they roll back, it may be months before they can go through CAB and security reviews, and the business is expecting the features they are trying to roll out now, not months from now. So the perception of safety and risk reduction and a central control ends up having the opposite effect. And on top of it, central control is slow. But at Amazon, we do not give in to the tyranny. We want both fast and safe. And this is why we use the concept of guardrails. Usually expressed as code, guardrails are established and standardized through a central team and delivered and updated to teams of builders in an automated and programmatic ways. There are a few different areas we tend to see operators working in. The new role of application operations in a modern serverless application is to set guardrails for these areas and deploy updates and changes throughout the organization. Often in this model, operations teams become part of a central platform team or cloud center of excellence. Here we have in a traditional application, there is one release pipeline shared between many teams. This process often introduces bottlenecks, which is why we decompose functional hierarchies at Amazon and gave teams more autonomy. When teams have the authority to move fast, they can release new features continuously, often several times per day. You can see from this design, teams are not encumbered by other teams to release. They release when they are ready and at a pace that aligns with their business objectives. Best practice is to have at least one pipeline per team, but that doesn't limit teams to only having one pipeline. At Amazon, a typical microservice will have an application code pipeline, an infrastructure pipeline, an OS patching pipeline, a configuration features flag pipeline, and an operator tools pipeline. By breaking up the pipeline into those mentioned components allows changes to those areas to be released independently. Now I want to go into a bit of a deep dive into the methodology and approach that Amazon uses to deploy. First, everything starts out as source code, and this includes application code, infrastructure code, patching code, configuration and feature flags, and operator tools. Builders will test when they are confident it's ready, and then they'll issue a pull request. As part of a pull request, several tests will be performed, such as static code analysis, security tests, and other tests that are relevant for the pipeline. As part of the pull request, a peer review is also requested, in which another team member will review code correctness and also evaluate whether changes can be safely deployed to production. They will evaluate whether the code has sufficient instrumentation for deployment monitoring and whether it can be safely rolled back. This is the last manual review, so it's a critical step. Once the source reviews are complete, the next phase, build, is where we compile code, complete unit tests, static analysis, code coverage checks, code review checks, then package and store artifacts. Once build is complete, the pipeline deploys and validates changes in multiple pre-production environments. For example, alpha, beta, and gamma. Alpha and beta validate the latest code functions as expected by running functional API tests and end-to-end integration tests. Gamma validates that the code is both functional and that it can be safely deployed to production. Gamma is as production-like as possible, including the same deployment configuration, the same monitoring and alarms, and the same continuous canary testing, and the same feature flags as production. Gamma is also deployed in multiple AWS regions to catch any potential impact from regional differences. Our number one objective for production deployments at AWS is to prevent negative impact to multiple regions at the same time and to multiple availability zones in the same region. Limiting the scope of each individual deployment limits the potential impact on customers from failed production deployments and prevents a multi-availability zone or multi-region impact. To limit the scope of automatic deployments, we split the production phase of the pipeline into many stages and many deployments to individual regions. Teams split regional deployments into even smaller scope deployments by deploying to individual availability zones or to their services, individual internal shards called cells in their pipeline. To further limit the scope of potential impact from a failed production deployment. So each team needs to balance the safety of small scope deployments with the speed at which they can deliver changes to customers in all regions. Deploying changes to 24 regions or 76 availability zones throughout the pipeline, one at a time, has the lowest risk of causing broad impact. But it could take weeks for the pipeline to deliver a change to customers globally. We have found that grouping deployments into waves of increasing size helps us achieve a good balance between deployment risk and speed. New changes can enter the production phase of the pipeline at any time. After a set of changes is promoted from the first step to the second step in wave 1, the next set of changes from gamma is promoted into the first step of wave 1, so we don't end up with large bundles of changes waiting to be deployed to production. The first two waves in the pipeline build the most confidence in the change. The first wave deploys to a region with a low number of requests to limit the possible impact of the first production deployment of the new change. The wave deploys to only one availability zone or cell at a time within that region to cautiously deploy the change across the region. The second wave then deploys to an availability zone or cell at a time in a region with a high number of requests, where it is highly likely that customers will exercise all the new code paths and where we get good validation of the changes. After we have higher confidence in the safety of the change from initial pipeline waves deployments, we can deploy to more and more regions in parallel in the same wave. For example, the pipeline deploys to 3 regions in wave 3. Then up to 12 regions in wave 4, then to the remaining regions in wave 5. The exact number and choice of regions in each of these waves and the number of waves in a service team's pipeline depend on the individual service's usage patterns and scale. The later waves in the pipeline still help us achieve our objective to prevent negative impact to the multiple availability zones in the same region. Then a wave deploys to multiple regions in parallel. It follows the same cautious rollout behavior for each region that was used in the initial waves. Each step in the wave only deploys to a single availability zone or cell from each region in the wave. The pipeline prevents automatic deployments to production when there is a higher risk of causing a negative impact. The pipeline uses a set of blockers that evaluate deployment risk. For example, automatically deploying a new change to prod when an issue is currently ongoing in an environment could make the impact worse or more prolonged. Before starting a new deployment to any prod stage, the pipeline checks the team's high severity aggregate alarm to determine whether there are any active issues. If the alarm is currently in the alarm state, the pipeline prevents the change from moving forward. Pipelines can also check organizational-wide alarms, like a large-scale event alarm that indicates whether there is a broad impact in another team's systems, and prevents starting a new deployment that could add to the overall impact. These deployment blockers can be overridden by developers when a change needs to be deployed to production to recover from a high severity issue. Automated deployments in the pipeline typically don't have a developer who actively watches each deployment to prod, checks the metrics, and manually rolls back if they see issues. These deployments are completely hands-off. The deployment system actively monitors an alarm to determine if it needs to automatically roll back a deployment. A rollback will switch the environment back to the container image, AWS Lambda function deployment package, or internal deployment package that we previously deployed. Our internal deployment packages are similar to container images because the packages are immutable and use a checksum to verify their integrity. Each microservice in each region typically has a high severity alarm that triggers on thresholds for the metric that impacts the service, customers, and on system health metrics like CPU utilization. This high severity alarm is used to page the on-call engineer and to automatically roll back the service if a deployment is in progress. Often the rollback is already in progress by the time the on-call engineer has been paged and starts engaging. Changes introduced by the deployment can have an impact on upstream and downstream microservices. So the deployment system needs to monitor the high severity alarm for the microservice under deployment and monitoring the high severity alarms for the team's other microservices to determine when to roll back. Deployed changes can also affect the metrics of continuous canary testing, so the deployment system additionally needs to monitor for failing canary tests to automatically roll back on all these possible areas of impact. Teams create high severity aggregate alarms for the deployment systems to monitor. So today at Amazon.com, we now have over 190 million deployments a year. When we talk about two pizza teams, culture, infrastructure as code, guardrails, teams with their own pipelines, and deployment methodology, remember that it has a practical application in the business. Interested in learning more about how Amazon builds and operates software? Check out the Amazon Builders Library, which is a collection of living articles and videos that give readers a look under the hood at how Amazon builds and operates the technologies that underpin Amazon.com and AWS. The Builders Library content is written by senior technical executives and engineers who are responsible for that topic on a daily basis and dives deep into the real-world practices used by Amazon every day. Now I want to turn things over to CloudBees, who's going to talk about feature flags and how those can be used to help accelerate while providing safety for your deployments.
Thanks, James.
All right, we have the second poll coming up now. Here we go. So pretty simple. How is your company utilizing feature flags today? Sorry about that. My microphone's being a bit weird. You have no usage, limited usage, heavy usage, or I'm not sure. Gonna give this a little bit more time. There, I think I fixed my microphone issue. Here we go. I'm gonna give this probably 5, 4, 3, 2, 1. All right. Pull up these results. Anyone want to comment on these before we move on to the next portion?
Yeah, absolutely, Max. I will. I think these are not surprising. The fact that nearly it's like 80% of you have either no usage or limited usage of feature flags today. I don't think this is really a surprise given where feature flags are at within the market and with their propensity and usage within enterprises at kind of that level of scale. But I think you're kind of at the right place, and we're going to talk about feature flags, but we're going to talk about feature flags mostly through the lens of what we've accomplished here at CloudBees built on top of AWS, and looking at the needs of our tool and what that means for the architecture that we built on AWS. So before we get started, though, we do want to give a very brief introduction to feature flags, just because understanding what they are and how they work is critical to understanding why we made the architecture decisions that we did on top of AWS. So, for those of you that are new to feature flags, and I think that's most of you at this point, what are they, right? They may also be known as feature flippers or feature toggles at your company, but at the most basic level, a feature flag is an if statement in your code. If something happens, then something else happens as well. But the key point of it is it happens without redeploying. So it happens remotely, and you don't have to roll, your entire version back. It's back in production. Changes happen in production there. I would note feature flags are not a brand new technology. They've been used by developers individually for some time, but the formalization of their usage and their management and their scale at the enterprise-wide level, this is a relatively new concept. And this is pioneered by the likes of Netflix and Uber and Facebook over the last 5 to 7 years. And the standardization of their usage within CI and CD tool chains, that's even rapidly growing today and being pioneered by the rest of the industry as they all catch up. So how do feature flags fit within the traditional software delivery lifecycle? Well, let's first think of the standard SDLC that I'm sure you're all familiar with. We have plan, design, that standard build, test, release and deploy one-step stage that are known as CI and CD. And of course, if you're familiar at all with CloudBees, this tends to be where we play, and we have solutions around CI and CD as well as feature flags. And of course, we have maintain. So looking at the SDLC again through the lens of feature flags in the mix, we get the following. Plan and design largely don't change. And really where you start to see the first impacts, it's in that standard CI/CD area. So if you think about it, CI is impacted with better builds by using feature flags to eliminate large feature branches and the all too common merge hell that is experienced by most developers when they're merging branches. Testing is impacted as testing can, certain elements of testing can now move to production versus everything pre-production environments. That's important, and that's something I'll touch on a bit more later. CD, is impacted as well because incomplete features can now be flagged off and deployed with the rest of a release without delays to that release for that feature. So that's important. It creates release velocity and standardization for those teams. But the biggest change, around feature flags, if you think about it in the realm of the SDLC, it's around breaking up the code deployment with the release of the feature. So when we think about this, code deployment, that is the technical act of moving code. So when something's deployed, that's the move. A feature release, though, this is a business decision of when customers get to receive that new feature. So feature flags allow you to move everything and deploy everything to production, but then it allows the business team to decide when new users see it, whether it's progressively, all at once, based on certain user characteristics that someone might have whatever it is, those actions are now decoupled. And that's a very, very powerful concept that, that feature flags provide. So as I said, testing in production is a big thing. You get to see impact analysis. You get to gradually roll out a feature. And by the time your entire user base has it, you should be confident that it's going to work as intended in production, and you don't need to roll it back. However, if you do need to roll it back, it is a simple feature kill switch. There's no need to do a massive full release rollback. It's just turning off that one feature at once, tweaking it, turning it back on. Again, it's kind of the new world with feature flags. So while that's interesting for the SDLC, when you think about feature flags in terms of the business value, it really comes down to three areas from our perspective. It's the reduction of risk. Being able to test in production allows teams to be certain of feature performance before releasing it to all users. The feature kill switch I mentioned, to immediately roll back buggy features without redeploying the release as a whole should make release managers very happy and just give one more layer of security and comfort when something goes out. We see feature flags improving developer productivity, and then this is again by enabling trunk-based development, decoupling the releases from the code deployments. This really frees up your development teams to just continue coding and not be held up by the business and when they want to push something out, or vice versa. It's really decoupled teams, allowing them to do what they do best. And testing in production, that this should speed up testing if done correctly and done safely, which feature flags enable. Finally, they feature flags shorten feedback loops, and they do this because, again, back to that concept of progressive delivery and slowly releasing code out to more and more users in production. So starting with your potentially internal QA testers, moving it out to beta users, and then slowly progressing it out to actual live users and monitoring the impact. By the time it's fully out, you should be confident that it works as intended. And I say shorten feedback loops because if a feature isn't working as intended, developers can see that right away and improve it before the entire user base gets it. So it's just a smaller blast radius for buggy features, for features that aren't well received, and it's more confidence pushing it out. So with that, I'm going to hand it over to Elliot, who's going to talk about, now that you have a context around our feature flags, what did we do to create our platform on top of AWS, and how did these two ideas kind of interplay with one another? So Elliot, go ahead.
All right, thanks so much, Nick. And the CloudBees Feature Flag platform has really grown into a full enterprise solution. And to help build this service first, we took a step back to see what all we really were looking to deliver in a product. So this kind of brings us to, at the most basic fundamental level, and now having a good understanding of what feature flags are, we needed to be able to provide a service that would allow users to configure a rule set that would be able to discern which sets of users should see a particular value of a feature flag, and then have a default setting for the other, ensuring that then these feature flag values are routed and serve users on the end devices themselves. So in all of these, we, at that overall basic level, we needed to make some take some considerations in how we were going to spend our time, our effort, and our engineering resources in architecting this platform and where we should really focus our time. And so the things that we'll kind of discuss today are, first and foremost, the speed at which feature flags are delivered and the architecture behind that. Because at the end of the day, when providing feature flags as a service, we need to make sure that they're delivered quickly. As Nick mentioned, if something does go wrong in production, having the ability to flip that switch instead of doing a arduous rollback process is extremely useful. But at the end of the day, it's of no use at all if after flipping that switch, it takes 30 minutes. We'll also talk about, in terms of scalability, we mentioned that the end devices themselves are the ones that are evaluating the feature flags, and our considerations of where these end devices might be and why we, instead of taking a more regionalized internal approach, decided to leverage outside help and really the specialized tools that AWS had to offer. And then finally, we'll, resiliency and kind of, where we could possibly fail and how, and what considerations we can take to ensure that if failures occur, there's a backup plan, because, people are less understanding when outages occur, but they occur frequently because you put all of your eggs in one basket. And at the end, we'll kind of talk about data privacy, because that is becoming, that has always been an issue and is becoming a growing issue. And we'll really discuss how that played a very important part in developing our architecture. So these were the considerations that we took into account. So let's fast forward to the end result and where we are today. And at a very high level, and we'll start in the lower left-hand corner with the computer image. We built a dashboard where a user can log in, make changes to a feature flag rule set. And this rule set is defined by what % of users should see a particular value. If we're doing a segment based approach, how is that segmentation defined? Or in other words, what user properties will be called on for correct flag evaluation? Am I using an email property? Am I using a user ID property? And then lastly, are there other flag dependencies? Or in other words, does the value served by feature flag A depend on feature flag B, C's value, et cetera? And so, after this rule set is created in the dashboard, all of this is then packaged into a JSON configuration file. And this is on our servers that, again, leveraged by the power of AWS's virtual private cloud, is then signed with the file is then signed with a public and private key. And we save the configuration file to Amazon's CloudFront in step 4 there, and simultaneously push a message via server sent event to the end devices where the SDK is installed and running. And so the server sent event message then notifies the end device itself that the latest configuration file is ready to be downloaded from its local CDN. And in that way, we're able to pull down those files and read and update feature flags on the device itself in a matter of milliseconds. And so we're truly proud of this architecture as an end result. But like we said, it took a lot of consideration, a lot of careful planning to get there. So on the next slide, we'll really focus on that first element, the speed. So in order for feature flags to be effective at all of the continuous delivery process and to truly decouple your deployments from releases, these feature flag deployments need to happen quickly. So we discussed that flags can mitigate risk. They can control the so-called blast radius, alluding to what Nick said earlier, by toggling a switch in the dashboard. And that switch sends a signal to restore a default or safe mode value. But this is all for naught if there's a high latency cost, and this could cost a business in customer retention, revenue loss, and overall corporate reputation. So with end devices needing these updated configuration files from our service, it was imperative that we build on top of a platform that leverages a tool with network layer optimizations and had the ability to serve our static configuration files. So this helped accelerate the download configuration process, allowed us to produce from the minute the rule set was updated in the dashboard to when they're read on the device itself is done in a matter of milliseconds. And it also allowed, so leveraging CloudFront also allowed us for caching and pulling mechanisms so that we could have these configuration files and constantly read from them. So again, just to reiterate here, using our own CDNs and kind of, taking an internal approach may have proved to be a short-term solution, but it would have had huge bottlenecks at scale. And this kind of brings us to our next point in scalability. So we, when we grow, we thought about, we need to be able to support millions of devices that are requesting configurations. And furthermore, these devices aren't going to be just located in one area. It's truly indicative of a growing worldwide customer base. So in summary, we really needed to be enterprise ready, and it was impractical, and it was really impractical on top of building support for various SDKs and JavaScript and Python, on top of all the work that already went into that, and then the work that went into building the platform, the UI and the various API itself, to spend additional time and resources to manage private CDNs to distribute the configurations. And this also allowed us to leverage S3 in a manner where the entire config file can be saved for scalable runtime evaluation on the device. It's offloaded to AWS. So no matter if it's one user, no matter if it's 1 million or 10 million users, it's always fetching that static config file. And again, using CloudFront, with 217 points of presences that, we ourselves definitely couldn't have done. It allowed us to focus on building the product at hand that we knew how to build, and let the experts take care, of the infrastructure that could deliver the configuration file. So overall, the opportunity cost was far too high, and it was best to leverage this infrastructure. But the consequences would have truly been dire, because standing up our own CDNs on top of EC2 and VPC usage would have meant supporting these resources and guaranteeing uptime. And with uptime, that kind of brings us to resiliency. So again, outages are unavoidable. People can understand that, but the understanding truly does stop when an outage occurs, and then that outage causes our customers to and affects their end user behavior or their customer behavior. So, think about the worst case scenario. Had we gone in and done a build it ourselves route, we would have had huge exposure to a single point of failure. If an error were to occur on our end, if an outage were to occur, not only would users signing into the platform be able to not push out the latest new configuration file, the last configuration file would be unattainable, and the only values that end users would be able to read would be default values in the code. So overall, this kind of illustrates that diversifying assets is not only sage advice in investment, it's also sage advice in architecting software. So we asked ourselves, how can we make it such that if there's an outage, that there's minimal impact, and we can kind of take our serving layer out of the critical path. And Amazon's guaranteed uptime, and when we saw this, it kind of allowed us to focus on a structure that mitigated these concerns. And so when we say that, when I mentioned our serving layer would not be part of the critical path, when I say that the CloudBees Feature Flags is not on the critical path to application usage, this just means that the interface making changes to a configuration file itself is actually decoupled from the SDK's ability on the end device end to evaluate flags. So the result means if our platform is now down, The worst case scenario is that new changes can't be made, but existing feature flag configurations can still be read from the CDN. And this architecture was designed to be stateless in this manner because there's no active connection between the end device and where the feature flag SDK is running and the serving layer itself. And so for our last piece of bonus content here, we understood the importance and the concerns around storing personal identifiable information. It's as important when we first created the platform as it is today. And using Amazon's resources, we were really able to distribute the configuration file, contain the rule set, rather than insisting that key value pairs relaying end user information, relaying it back to our servers, and then in turn evaluating the rules on our side and just returning the end value of the flags. So now we're able to create the entire rule set in the dashboard, and no user data is ever leaving the end device, because you may recall from our previous architecture slide at the beginning, all the decision points, all the evaluation is happening on the device itself. And this is because all references to properties for user segmentation, discerning which user is seeing which flag at any given time, is all done using local function calls. So in summary, overall, we were able to incorporate AWS's architecture. And with that, it saved us time and allowed us to work more on the elements that that allowed us to engineer a better overall platform, and it was supported by a better overall architecture than we could have done alone, and it minimized our worry involved on that end. And so, since we could instead focus on the platform and engineering that part ourselves, we can now deliver new functionality with less resources than the alternative scenario where we are spreading ourselves too thin across managing and supporting the infrastructure, as well as finding engineering time and resources to develop new features, and also supporting our own product as well. And so Amazon's leading uptime and worldwide coverage, including portions of the world where other CDN services truly struggle, really helped contribute to the growth of our product, while we could continue to build a model that alleviated security concerns. So, applying this today, kind of abstracting this entire process for getting started on your end, work backwards from your application's needs and your must-haves and what you're looking to deliver, and then offload any non-proprietary work. Leverage your team's knowledge and expertise, and use the theory of economic specialization, creating those competitive advantages and leveraging opportunity costs to allow your team to focus their time and energy on what they and only they can do best, and then using other tools that specialize in providing services in what they do best. And then, be optimistic and pessimistic about your future. Plan for the worst case scenario. And this really does help keep a healthy balance with both scalability and resiliency. And, I guess on a last note, if you can take anything away from our experience, we really appreciate all the help and support provided from the AWS team, and couldn't give a higher recommendation. And with that, Nick, I'll turn it back over to you.
Thanks, Elliot. All right, we're about to open it up to questions, but before we do that, I just want to plug, if you do want to get started with feature flags, we do offer a 14-day trial, as well as moving into a free forever option for one user to get started, to kind of see how this service works in itself. And we are very happy to announce CloudBees Feature Flags is now available on the AWS Marketplace. So if you happen to be a customer on the AWS Marketplace as it is, this drastically speeds up procurement and the time between getting the tool purchased as well as getting it utilized at your end company. So with that, I see this, we're going to have some questions coming in here, and we will read through them and get to them as we can. So.
All right, you can put the questions in either the chat or the question and answer section. Nick, Elliot, James, if any of you have seen any come in, or if you have any of your own, we can go ahead and get started with one of those. Quiet group today.
All right. Looks like we do have one question specifically on feature flags, just around technical debt. I've heard of feature flags, but do they create technical debt for my company? So that's specifically around just our tool versus AWS. Elliot, do you want to answer that question?
Yeah, absolutely. So, technical debt and feature flags kind of go hand in hand, and it's unavoidable. The best way to kind of tackle it, though, is to build best practices around it, whether it be attaching it to a Jira ticket or monitoring how many feature flags you have in your system at any given time. We've heard of companies that kind of institute a feature flag limit, so that if you're approaching this limit, if you have 500 feature flags in your system and that's the limit, on that 501st feature flag, a notification will be raised saying that you have to delete another one in order to put one in. Linking members of your team to a particular feature flag, and also denoting how long a particular feature flag is going to live in your system, that would really help the cleanup process and really mitigate any concerns around technical debt.
All right, we have another question coming in. What was the exact name on the AWS Marketplace? I skipped it. This question, simply, if you go to the AWS Marketplace, you put in CloudBees Feature Flags, it should come up right away. We also have our CI solution on there as well for both standard Marketplace as well as AWS GovCloud. So should be hopefully easy to find.
Do this one more minute, see if anyone else has any more questions. All right. So, Nick, it looks like questions have been answered today. Oh, wait. Nope, sorry. We just got one in. Is it possible for an entire team to use one of those one-user accounts for trying out the solution?
The short answer is no. It's one user at a time. So of course, you could do your trials with that. We do offer very simple, one user to team migration packages with our tool, but the quote freemium option that we have for feature flags is for specifically one user on the back end. So. And we are getting multiple requests to share the presentation. Of course, we will do so. You will receive an email with the recording either today or tomorrow. So.
Nick, Elliot, James, I think we're wrapping it up for today. Do any of you have anything you want to share before we let everyone go?
I think that's it. Thank you all for your time and your attendance today, and we hope you have a good rest of your week. Bye-bye.
Thanks, everyone. Thanks,
Thank you so
Elliot,
much.
Nick, and James for presenting.
You're very welcome.
Talk to you all soon.